So in this video, we're going to talk about how to solve problems with logarithmic equations. So remember, we can convert between exponential form and logarithmic form using the relationship that a equals b to the x means that log base b of a equals x, where b is the base of the logarithm. So this concept can be used to solve logarithmic equations. So remember, when you're evaluating logarithmic expressions, you're going to start off by setting the expression equal to x. Then you rewrite the equation as an exponential equation, and then you can solve by rewriting it so that the bases are the same. You're going to set the exponents equal to each other in order to solve. So let's try finding the log of 1,000. So remember, we start off by saying that this means that the log of 1,000 equals x. Well, the log of 1,000, remember, that's the common log, so that's the log base 10 of 1,000. So we can rewrite this by saying that 10 to the x equals 1,000. Well, if we look at our powers chart, notice that both of these are powers of 10. So we can say that that means that 10 to the x equals 10 to the third. So 10 to the x equals 10 to the third. Now we have the same base, so that means that x equals 3. So now let's try finding the value of log of 1/10. So once again, this is the common log. So this is the log base 10 of 1 over 10. And remember that we can set this equal to x. Well, this is 1 over 10 to the 1, right? So whenever we have the reciprocal, we can write that as a negative exponent. So that's the log base 10 of 10 to the negative 1, and that equals x. So we can rewrite this in exponential form. So we can say that 10 to the x equals 10 to the negative 1. So since we have the same base, that tells us that x equals negative 1. So now let's find the value of the log of 0.01. So once again, this is the common log. So this is the log base 10 of 0.01, and we can say that equals x. Now we can rewrite this in exponential form. So we can say that 10 to the x equals 0.01. Well, 0.01 is one of those powers of 10. So we can say that 10 to the x equals 10 to the negative 2. Now we can set these two exponents equal to each other, so we have x equals negative 2. So logarithms can be used to solve many real-life problems. So one place we see logs are when we're talking about the decibel scale, which tells us the intensity of a sound. So the intensity of a sound is measured in a unit called the decibel. It's measured as a ratio comparing the sound being measured to the faintest sound detectable by the human ear, which is the threshold of hearing. So this formula tells you the intensity of a sound R in decibels, which is R equals 10 log I over I naught, where I is the intensity of the sound being measured, and I naught is the faintest sound detectable by the human ear. The intensity of a whisper is about 100 times greater than the threshold of hearing, so I over I naught equals 100. Calculate the decibel measure of a whisper. Okay, so let's look at the important information here. So we have R in decibels, which is given by this equation. I is the intensity of the sound, and then I naught is the threshold of hearing. So we're thinking about a whisper where we have I over I naught equals 100. So we're going to calculate the decibel measure of a whisper. So we want to figure out R, right? So we have R equals 10 times the log of I over I naught, which it tells us is 100 in this case. Okay, so what we can do is we can use exponential form to rewrite this, right? So we can say that this is R equals 10, and then remember, this is the common log, so 10 log base 10 of 100. So I'm going to use that property of logarithms backwards. Remember that we have the log base b of a to the m equals m times the log base b of a, right? So remember that exponent can come in front and become a factor. So I'm going to use that property backwards, and I'm going to push this 10 back up here and make it an exponent. So I have r equals the log base 10 of 100 to the 10th. So what I can do now is I can rewrite this in exponential form, right? So if I put the r over here, you can see that this tells me that 10 to the r equals 100 to the 10th, right? So 10 to the r equals 100 to the 10th power. And now let's rewrite that 100 as a power of 10. 100 is 10 squared, so I have 10 to the r equals 10 squared to the 10th power, right? And then I can use that product property, so I can say that 10 to the r equals 10 to the 2 times 10, which is 20, which does tell me that r equals 20, right? So 20 decibels is how loud a whisper is. So let's use the same formula and the same relationship to figure out the sound of a garbage disposal. It says the intensity of a garbage disposal is about 10 to the 8th times greater than the threshold of hearing. So let's calculate the decibel measure. So we're going to use the same formula, but we're just figuring out the sound of a garbage disposal. So we have R equals 10 log, and then I over I naught in this case is 10 to the 8th. Once again, I'm going to use that same power property backwards. I'm going to move this back up here. So this becomes R equals log of 10 to the 8th to the 10th power, right? So I can go ahead and multiply those exponents together. So I get R equals the log of 10 to the 8 times 10. So that's 10 to the 80th. So I'm going to now rewrite this in exponential form, right? This is a log base 10. So I'm going to rewrite this. And so that gives me that 10 to the R equals 10 to the 80. So that basically tells me that R equals 80, right? So 80 decibels is the loudness of a garbage disposal. So another place that we see logarithms being used is the pH scale. So the pH scale, we say that pH equals negative log of H plus, which this tells us the concentration of hydrogen ions in a solution. So the function f of x equals negative log of x measures the pH of a substance where H is the hydrogen ion concentration of the substance measured in moles per liter. Most substances range in pH from 0 to 14. The table shows the pH level of common substances. What is the hydrogen ion concentration x of each solution? And then explain how the hydrogen ion concentration of soapy water compares to that of milk. Okay, so we have this relationship f of x equals negative log x. And we have these two substances described here. Okay, so let's figure out the hydrogen ion concentrations. So first, let's start off with the soapy water. So we're going to plug into this formula. So we have f of x, so that is the pH, right? So the pH is what's given here. So we have 12 equals negative log of x. And we want to figure out what x is. Well, I'm going to start off by taking care of that negative, right? So that negative is basically a negative 1, so I can actually divide both sides by negative 1. So that gives me negative 12 equals the log of x. So just so you can see what I'm doing, I'm going to flip this equation. I'm going to write this as the log of x equals negative 12. Well, now you can see this is the common log, so I can rewrite this in exponential form. So this tells me that 10 to the negative 12 equals x. So 10 to the negative 12 moles per liter is the concentration of hydrogen ions for soapy water. Okay, so now let's figure out the concentration of hydrogen ions in milk. Milk, it tells us, has a pH of 6. So I'm going to go ahead and work on that. So I have negative log of x, and so that equals 6. Okay, once again, I'm going to divide both sides by negative 1. And so that tells me that the log of x equals negative 6. Remember, this is the log base 10, so I can rewrite in exponential form. So that tells me that 10 to the negative 6 equals x. So 10 to the negative 6 moles per liter is the hydrogen ion concentration for milk. So now it wants us to compare how the hydrogen ion concentration of soapy water compares to that of milk. Okay, so we have soapy water, which we said was 10 to the negative 12. And then we had milk, which was 10 to the negative 6, right? So if we compare to these two, we can say that that's like an exponential equation. So we can do 10 to the negative 12 minus negative 6, right? Because remember, when we have a to the m over a to the n, we can just subtract those two exponents. So that's going to give us 10 to the negative 12 plus 6. So that's 10 to the negative 6. Okay, so that means that milk has 10 to the 6th more hydrogen ions than soapy water. Okay, so that's how you can describe the relationship between those two substances. So remember that logarithms can be applied to solve many real life problems, including problems involving the loudness of sound and the pH scale.